a girl
and her gay watch The Magic School Bus.
It's the show where we yap about life, science, and go on an occasional rant about the state of the world. I'm Sarah.
And I'm Matt. We're your hosts, and we're here to invite you to our weekly yap sesh, bring you some 90s and 2000s nostalgia, and maybe teach you a little science.
Every Wednesday, we're hopping on the Magic School Bus, unpacking the science without the pressure of a pop quiz, and I'll be asking the questions I was too bored or afraid to ask in school.
Curiosity leads.
Chaos follows.
Welcome back to another episode of A Girl and Her Gay Watch, The Magic School Bus. Today we have watched episode 9 of season 1, Ready, Set, Dough.
Mm-hmm.
Sarah, before we get into the episode recap, I have some very special news to share.
Tell me.
There has been a new addition to the Love Family Farm.
I could cry.
We have a little bebe cow.
Oh my God, tell me everything about him.
He's adorable. He's a Jersey. So he is a very, very fashionable brown and black color. All brown, tan with a black little nose, black little hooves, black little snoot.
Oh,
I think I said nose already, but you know.
I'll take it. And his little snoot is like shining in the sun. And his little tooth.
His little bottom tooths.
Oh my God.
Because you know cows don't have top teeth.
And I don't love that about them.
I think they have top molars in the back for grinding. But
interesting. Well, they have that like kind of plate palette thing for fascinating.
Bit of an internal mortar and pestle situation.
I adore him.
Getting his little daily bottles.
Well, we're here. We watched a show.
Yeah. Should I recap it for us?
Please tell the people what we just witnessed.
All righty. So in today's episode, we open with the bus being a little sick. Something was going on. Frizzle was out there in her mechanic's jumpsuit and toolbox earrings, working on trying to figure out what was wrong with the flugelhorn.
Yeah.
And then we like cut to inside, and the kids are like dress rehearsaling a surprise party with full confetti for some reason. And DA is working on her chemistry homework that she didn't do, which doesn't seem like a very DA thing to do, but
no, I think it was extra credit. Like she doesn't seem like a late assignment kind of girl.
Miss Frizzle comes in and she is like, our field trip must be canceled because the bus is not working up. And the kids are all like, but we don't have a cake for the surprise party, and we were supposed to go to the bakery, and we must get a cake, so we have to go to the bakery. So they like give her sad puppy dog eyes and are like, no, we have to go to the bakery. Our education will be incomplete without it. This is a
super
tragedy.
manipulative.
Yeah. So she's like, all right, bus is acting a fool, but let's go. So they get to the bakery, and the bus does act up and like shrinks them all down, and they like still go into the bakery in the shrunk down bus, and then they like tell Miss Frizzle to go to the auto mechanics store down the street to try and get parts for the Magic School Bus, because like, you know, most auto mechanics just carry Magic School Bus parts. And so she leaves with a jetpack, still shrunk, and they get busy making a cake. The baker is around. He thinks they're a moth and is chasing them with a fly swatter.
Mm-hmm.
It all culminates with they fall into the batter and get baked inside of a cake. The lizard who's been in charge the whole time doesn't put up the heat shields, and it becomes very tense for a moment until Miss Frizzle returns and is like, just press that button. They escape the cake and get back to the school where they have their surprise party, and Miss Frizzle cuts into her cake, and there's a little bus-sized hole in it.
Beautiful. I don't know what they were celebrating, to be honest.
Her birthday.
Was it her birthday?
It was her birthday.
Oh, okay. I think because at the time of recording, I think we're in like Teacher Appreciation Week or something. So I was like, Is this conveniently timed? Okay.
No, that
her
was last
birthday.
week, was Teacher Appreciation Week, actually. But
In and around the season of Teacher Appreciation Week. I'm sorry, you only want them to have 1 week, Matthew.
I'm sorry you don't appreciate them enough to know when their week is.
I knew that it was nowish. I think teachers should always be appreciated. Every week should be Teacher Appreciation Week.
I agree. Yeah. Well, that was the bit at the end where it was like, you never said how old Miss Frizzle is.
Oh, that makes so much more sense.
Yeah.
Okay, cool.
Chemistry. I'm excited.
Yeah. So the whole episode was leveraging the process of making a cake to explain some elementary chemistry principles,
Yes.
fundamentals, right? Are you ready for me?
I'm so excited. I'm ready.
I know. Matt's been like looking forward to this episode because, as he has so proudly proclaimed, chemistry is a strong suit.
We'll see. Our audience may disagree after.
Well, you know me, I'm probably not going to ask any relevant questions at all. So you're like, great, my one chance to shine. And Sarah's asked me questions that don't matter. I'm going to start off super easy. What is chemistry? You can look it up.
Yeah, definitionally.
Yeah.
Chemistry. I mean, chemistry is just the study of matter, really. And that's like the broad definition. But like when you think of like school chemistry, you're thinking of like periodic table, elements, atoms, interactions between atoms, molecules, compounds, changes in physical state. Up in the upper levels, we get in blended with some physics as well.
Mm-hmm.
So that's chemistry.
Okay,
broadly.
cool. So you kind of touched on it. I wanted to ask sort of what the major players are in the space of chemistry. Not mitochondria.
No, that's the powerhouse of the cell.
Yeah, famously. So atoms, molecules, them moving around, sticking to each other in different various combinations to create new and different things.
Yeah.
And then the states in which they exist. Solid,
Mhm.
gas,
Yep.
and
Only
liquid.
one more. Yeah, there you go.
Okay. Go me. Okay.
Those are the basics. We won't get into like supercritical fluids.
Please don't. Thank you so much. At least not this early on. We got to ease the people in. There's a method to my madness, okay? We start gentle and then we get into some insanity. Curiosity leads.
Chaos follows.
So, I wanted to ask you also off the bat, we've toyed around with and referenced a lot.
A flirtation, if you will.
A flirtation. It really has been like a little, it's kind of been a little secret love affair of ours. Discussing physics. What's the difference between chemistry and physics?
Yeah. So physics, I would say, is primarily the study of motion and forces. But like electromagnetics and electricity get in there too, I guess because of electrical force. And so that's where you sort of get the overlap is like electromagnetism and electromagnetic spectrum overlaps in a lot of chemistry because light is how we do a lot of experiments because we can use the kinds of light that it absorbs, reflects back. Light can excite different parts of a molecule so that we can visualize them. And so there's a lot of overlap there in the field of spectroscopy. It's used a ton. And then I would also say just like the electronics of it all, like electrons moving and the motion of particles and atoms relative to one another really blends over with physics. There's a whole study of chemistry within chemistry called physical chemistry that sort of studies that area of overlap.
Ooh, fun. Okay. Thank you for clarifying. Can I ask you about just some basics of chemical reactions?
Yeah.
So we'll start off at the beginning. What qualifies as a chemical reaction?
Yeah. So this is one of the things we teach early on in chemistry is like there's a difference between a physical change and a chemical change.
Right.
So like something melting it's still water. Like, let's say we're using water, for example.
Sure.
It's still water. It's just in a different phase of matter based on the temperature or pressure. That's a physical change. Nothing chemical has happened.
Okay.
Whereas using electricity to break water apart into hydrogen and oxygen, that is a chemical change. So, two different substances have been produced from the chemical reaction.
Mm, okay. So that's kind of where I wanted to get into was like, let's just stick with water.
Mhm.
So I have a couple curiosities around just like the phases that we talked about. So water as a liquid. So when it freezes into ice, that's just a physical change.
Yes.
Okay. Why does the volume, I guess, get bigger when it's frozen?
Yeah. So, water's a weird one. It's the only thing.
That's crazy.
Yeah, I know. It's the only thing that does that.
Well, that was my follow-up question is like, do things get smaller?
Typically, volume decreases from gas to liquid, liquid to solid.
Mm.
But water is weird. And it's fantastic that water is weird because it's why water is so great for life.
Oh,
Because the unique properties of water uniquely support life. So, because water, let's back up a little more.
sure.
So, you have ionic and covalent bonds, which are the two major types of bonds that can form.
Hmm.
Ionic bonds occur when an electron is completely stripped away from one atom and given to another one.
Okay.
So, like salt, sodium chloride is an ionic bond. Um, the reason why sodium and chlorine, once they've undergone this ionic bonding, stick together is because while sodium has stolen an yes, no, sodium has lost an electron to chlorine. Sodium, now that it's lost an electron, electrons are negatively charged, is slightly positive. It has a positive charge because there are
Mm,
protons. And chlorine, having taken those electrons, is now slightly negative,
right.
and they stick together like little magnets.
I,
And if you want to think of it as a spectrum, you sort of can.
and I will.
Fully, like the best example of ionic is on one side, and the best example of covalent is on the other. And the way that covalents work is that they will share electrons with one another. So they kind of like aren't fully pulled away by one. They just kind of spend their time splitting between.
Okay.
Okay. And so the electron count that they need to have is almost always 8, with the exception of like hydrogen, helium.
Okay.
And so, like, if one has 3, one has 5, they might just hang out together and share those 8 as their outer shell of electrons. Um, but thinking of it as a spectrum is helpful because in some instances, there are shared electrons, but one atom wants them more than the other and like holds them a little closer to it. Right. So it's like trying to completely rip them away, but it can't.
Mm,
But in that, it's like a tug of war where it's shifted closer,
little love triangle.
yeah, to the one. And so that's where water falls. And so
Okay.
water is what we would call polar, meaning the electrons spend a lot more time with the oxygen than they do with the hydrogen. And so you get a
Mm.
partially negative charge on the oxygen and a partially positive charge on the hydrogen.
And partial charging is rare or just
Um,
in this like liquid kind of
it's pretty
situation?
common with what we call polar covalent compounds.
Okay.
And those are these types of compounds where they are sharing those electrons, but they are not fully like removing them from the other atom.
Okay. I guess I'm just trying to place when you say that the way that water acts is weird.
Oh, okay.
Like, how so and why?
Yeah. So water is about as close as you can be to being ionic without actually being ionic. So
Mm,
there's a pretty strong polarity there,
okay.
which makes it unique. And I don't recall specifically, but I do think for liquids, like in general, having a strong polarity is liquids at room temperature, having a
Mm,
strong polarity is kind of unique. Not that there aren't polar liquids, but some of them are more weakly polar.
mm,
So anyway, what happens is because of that polarity, when water goes to freeze, it creates this what we call a crystalline lattice, where
that's a good drag name.
crystalline lattice,
Yeah.
yeah, where water, the partial negative side of water and the partial positive side of water are attracted to each other, but then where they're like partial positive next to partial positive, they repel. And that's sort of what creates this expansion when it freezes, is the molecules like
Okay.
orienting themselves based on their polarity.
Okay. Question.
Yeah,
The space between. We've talked about this
the
before.
space between.
So it expands because it's like, opposite sides of magnets, right? They're like, "Ugh, give me
Yeah.
away." What's in the middle that's creating the volume?
So it's just electromagnetic force holding them.
It's not a real
Um,
thing. It's not a real thing.
I mean, it's very much a real
It's a
thing,
real thing, but it's not
but
a.
you can't see it or feel it or like really on a,
That don't keep me warm at night.
yeah, you can't know it in the way you can know an apple, right?
Yeah. Okay.
Yeah. So it's just
I don't like that.
the
I'll
space
accept
between
it
is just
begrudgingly.
space.
And it's something, but it's nothing. And it is creating like a visual
Yeah. It's
something.
more nothing than something.
You keep saying stuff like that. Okay. So liquid water
Mhm.
to ice,
Mhm.
physical change.
Yes.
Liquid water to steam, gas, chemical change,
Physical change.
physical change. Nothing changes.
It's just getting enough energy in the molecules that they're able to overcome their attraction to one another and become a gas and spend more time further apart.
You should write a self help book for people everywhere trying to get over their ex.
um,
Change your physical.
yeah.
A chemist's guide.
So, a chemical change example I kind of said before would be if you run electricity through water, it will fully split the hydrogen from the oxygen,
Hmm.
and then you'll have hydrogen.
What does that look like? Okay, I guess in my brain, when you said run electricity through it, I'm like, well, my stove is electricity.
Yeah, so if you put a toaster in your bathtub,
Don't tempt me.
if you ran electric wire through water, you'll start
Mm.
to see bubbles form.
Mm.
And those bubbles are what we call it being electrolyzed. Yeah, it's electrolysis.
Oh, people do that to stop sweating.
Yeah, I think it's a little different,
I'm
but
sure it's got some nuance to it. I just wanted to be
like
really clear. Don't put your toaster in a bathtub if you have sweaty palms. We are not telling you to do that, people.
it will fix the sweaty palms,
Yeah, you'll never sweat again.
but in a very permanent way that you don't want.
Oh my God, that's awful. Okay, I'm a little, I fear chemical reaction. It might be too high of a concept for me at this time. You're disappointed to hear it. But like, I understand that I can see the bubbles. But like me diving into a pool and letting out all the air, I can see bubbles, and that's not a chemical reaction.
Yeah. So, right. And if you boil water, you see bubbles, right?
Right.
So it is an indicator that they're bubbling is an indicator that a chemical reaction might be going on, but it is not enough to say for sure, right?
Okay.
So some of the signs of a chemical reaction are change in color.
Toast.
Yep. Change in temperature without externally heating or cooling it. What?
I'm processing. Changing temperature without externally heating or cooling it.
Yes.
Like those little hand warmers that you have when you snap the thing. To give people a better explanation than what I just said, because I don't know what they are.
The hand warmers that I have are, and this is going to upset you. You're going to be very upset.
Just tell the people and I won't listen.
The hand warmers are a gel that have a little metal piece in them. And when you snap the metal, it causes the fluid inside to crystallize and they release heat. That's a physical change. I'm so sorry.
Oh my God.
I'm so sorry. I'm so sorry. Now,
how am I ever going to like science? Every single episode you have deeply upset me, and not in like my world's changed and like I'm never going to understand this. We might need to do chemistry only summer school as like our between season releases, because this is not fair.
Well, and here's the thing, right? Is chemistry is a big discipline.
And I am so undisciplined.
And you get like very little instruction on it, right? A lot of the science education you get is biology based.
Yeah.
You get very little physical science, at least in the curriculum we were brought up in. And also knowing the current curriculum, having taught.
And I do want to get there from like your teacher lens of like learning about this stuff, because I mean, I had a fully dedicated chemistry class with one of the best chemistry instructors, period. And like, I remember, shout out our mutual, Dawn. She was in AP chemistry with you, or like...
Yeah, with me.
Yeah, I think she was in your class. She lived in my neighborhood. She would give me rides home. And like, I was in regular kid chemistry and she was in AP chemistry, and I'm like crying because I cannot... To be fair, it was the first time I was ever introduced to the idea of any of this stuff, because we didn't have science education at Christian school.
I was going to say, I imagine you coming up through Christian school, you probably didn't get any chemistry until then. Not even foundational. So.
No, I could do all the math that was required. And so that's why they put me in there. But like the base level understanding of like compounds and whatnot, I'm totally lost.
Yeah. We still treat high school chemistry as if it's the first time you've ever seen any of it. But if you've seen it a little bit before, even if you didn't understand it, I think it just gives your brain something to latch onto to then try and make sense of it, which is really hard if it's truly the first time you're ever seeing it.
Yeah, we just truly did not have like any science education in my former curriculum. So okay. I'm calming down from my emotional reaction. Heating, temperature change without externally heating or cooling. And not in the thing that I said, because that is obviously a physical change, not a chemical reaction. How silly of me.
No, you would have no way of knowing that without knowing it.
Okay, I'm proud of the try, but I don't like being wrong.
Hand warmers are not a bad example, though. Just not those hand warmers.
Okay, like the therma
the
hand
like hot
ones?
hands,
Hot hands,
that you get, they react with the air. That chemical, when it interacts with air, does a chemical reaction that releases heat.
Okay.
So that is a chemical reaction happening. There are also those like ice packs that you pop the little thing inside and shake.
Those are fun.
Those are a chemical reaction where they change temperature in a cool way. Yep.
Super cooling, when like you reach that magic spot on if you put your water in the freezer and then you like flick it and then it like crystallizes.
Yes.
Is that physical change?
Perfect. So that's exactly what's happening with those hand warmers that I have.
Oh, okay.
Is that the the dissolved stuff in that gel has been dissolved beyond the point where it really should be able to hold that salt in a liquid. And then when you snap that thing, it creates a disturbance that allows it to crystallize, and then it
Okay.
immediately crystallizes.
Cool. Okay. Don't understand why that makes it hot, but we're going to keep forward momenting.
Yeah. Basically, because it's just the way that the energy is stored in the molecule. So molecules can store energy.
Mm-hmm.
And basically, in its crystal form, it's in a lower energy state. And so it needs to release that energy somewhere.
Okay.
And the two ways that it could do that are through heat and light.
Okay.
And so heat is the one that we experience. It probably also emits light, just not in a wavelength that we can see.
Yeah. Interesting.
While we're talking about chemical reactions that produce heat and light, can we talk a little bit about fire?
Yeah, let's talk about fire.
So fire, it blew my mind when I first realized it, but like the fire isn't like a thing.
The actual flame?
Yes.
Okay.
It is just you observing the heat and the light produced by a chemical reaction.
Okay. Does that chemical reaction have a name?
Combustion.
Yeah. And that was a question that I knew the answer to as soon as you said it. Okay.
Yeah.
So why can we see that combustion, but we can't see other combustion?
It's the, well, we can see a lot of combustion, but it is based on just the sheer amount of energy that it releases, right?
Okay.
So, sort of tying back into biology, when plants grow, like i.e., trees, wood, they're storing a ton of energy to like organize those molecules in a way that makes cellulose that builds this tree that grows really tall and like, absorbs sugars and whatever. So when you cut it down and chop up the wood, all that energy is still stored there. And once you get a fire going, that is completely disorganizing all of those carbon molecules that were in the cellulose. And because they're being broken apart and disorganized, they're releasing that energy back out instantly in the form of heat and light.
Okay. Great. I think I understand that.
Yeah.
Sorry, sometimes I give you a delayed reaction, but it's just like my brain kind of like making its little connections in a way to make sure like, do I have any follow-up questions about this? Like,
Yeah.
I think that actually makes sense.
Fantastic.
Yay. We get it. Okay. Chemical reactions.
Yep.
So you were talking to me about some certain types. Were there any other types that you wanted to mention? Or like temperature change?
Oh, the signs of chemical reaction. So it's temperature change, gas produced, color change.
Gas produced, but water turning into steam is not.
Right. So I said signs that it might be a chemical reaction. Not for sure indicators.
Oh, I thought that was just about the bubbles. Okay, fine.
But gas produced.
Okay.
And I feel like I'm missing one, but I can't think of what it might be. Oh, precipitate. Precipitate formation is the final one. And that's a solid being produced when you mix two liquids.
Like?
I don't have a great example of one that you might be immediately familiar with.
Like vinegar and milk makes a curdle. That's a physical change.
Probably a chemical change.
Okay.
That's very likely a chemical change. I don't know that. I mean, it is.
You're not impressed with it, but
no. You're making me think about it.
Okay.
Can we consider curdling to be a precipitate? I think so. Because you've mixed two liquids and it produced something solid.
Or did it just like exacerbate the solids that were already in the liquid? Because milk does have like
That's
fat
true.
solids in.
I don't know. I mean, it's definitely a protein thing, right?
God, and as we've learned on almost every episode, those guys are doing too much out here in the world.
So I did some research about curdling.
I regret instantly even bringing it up.
Yeah. So turns out I don't actually think it's a real chemical reaction.
Yeah.
It was described to me in my reading as a physiochemical change. I'm so sorry.
This is going to have to be another end of season compilation. All the times I just get angry.
And what they mean by that, I believe, is that the chemical conditions of the solution have changed by introduction of acid. So you've made the solution acidic, whereas milk is normally like a weak base. And in the presence of acid, the proteins in milk that normally are emulsified and floating are able to be attracted to one another. And so they clump up.
Okay.
So it's not exactly a precipitate. You honestly, though, you'll have to Google precipitation reactions. Some of them are very cool.
Okay.
Like you mix two liquids together and all of a sudden it just like starts snowing out like a very fine white powder. Yeah.
What about elephant's toothpaste?
That one
What's in there?
Is very similar to like a vinegar baking soda reaction.
Okay.
With the addition of soap and food dye.
Yeah. Okay. So it creates the gas, but then the soap
makes the bubbles.
Like the volume.
Like,
okay. Okay. Gotcha.
Some of them, well, and then there's one that it actually is the two chemicals and an indicator. So an indicator is a chemical that isn't necessarily participating in the reaction, but is impacted by the reaction. So there are indicators. What? Yeah, exactly. They're just watching. They're just watching.
Got it. Sorry.
So an indicator is affected by pH, and oftentimes that change in pH will change the color of the indicator.
Fun.
And so, there's pH test strips.
I know them.
Yeah, it just uses an indicator. So that indicator changes color based on how acidic it is, and you can match that up to a little key.
Cool.
And so, like, there's a pink and orange one, I think, and it might be even two different indicators. But in like acid, it'll be pink, and in base, it'll be orange. And then when you do that reaction, it doesn't do a complete reaction. So like some of the acid gets pushed out before it has a chance to react. That stays pink and others stays orange. So you get like a fun color. And it's really, those are just kind of tools where chemistry teachers are taking a chemical reaction that would be very unexciting and making it a little more spectacular to like get interest and like get people curious.
Give them the old razzle dazzle.
Yeah. Razzle dazzle them.
Thank you. Okay. Very cool. So chemical reactions.
Gas.
Yeah.
Color change. Temperature.
I wanted to
precipitate.
ask why. I guess I don't really know how to ask the question, but my curiosity is around how long some of these chemical reactions take. Some of them are instant.
Yes.
And some of them seem to just move at a glacial pace, and you know how that thrills me.
Yeah.
So what is happening and why? And are the things really like just detaching?
Yeah. So there's a whole study in chemistry called kinetics that is the study of this. And it is how fast or slow do reactions proceed.
Okay.
And there's a variety of reasons why that can happen, right? So in order for a reaction to occur, the molecules have to interact with one another. And so a lot of the chemistry that we do is done in liquids because it gives the chemicals more opportunity to interact with one another, right? Just mixing solids together, the molecules aren't moving around as much. They're not having as much chance to interact with one another. Whereas in a liquid, liquids flow, they move, they, can be stirred. So that can speed up the reaction. And then there's a variety of other things that can speed up reactions. So we've talked about enzymes a little bit already.
Mhm.
Um, enzymes are a protein that act as a catalyst. And so we'll talk just kind of generically about catalysts. Catalysts are anything that can speed up a reaction.
Mm.
So in some cases, it's just like you put in platinum shavings because platinum has an abundance of electrons and so then there are extra electrons around for the chemistry to happen, right?
Gotcha.
And the platinum's not really impacted by that reaction. It just like lends its electrons for the reaction to happen and gets them back.
Cool.
And that is pretty traditionally when we think of like a basic catalyzed reaction, the catalyst should not get used up in the reaction. If it's used up, it's becoming part of the reaction. It's not a
Sure.
true catalyst.
Okay.
And then in terms of chemical reaction speed, I mean, there's just a variety of factors. Some of them require an activation energy. So the energy of the system has to get high enough that the chemical reaction can occur.
Mm.
So it may take a very long time for that activation energy to build, but then once it builds, it like happens very quickly. So you can sort of think of like fire is a good example of that, right? Where you have to inject heat into it to get it
Mhm.
started. But once it's started, it sort of self
Mhm.
um, replicates, I guess. It like keeps itself going.
Okay. Mhm.
Does that answer your question?
I think so. We'll cut out me sitting here in stunned silence.
Yeah, I mean, kinetics is one of those things where like I have a basic understanding of it. I don't necessarily know
Sure.
all the ins and outs.
I don't think we'll get there.
Yeah.
Something.
We're already at 55 minutes.
Yeah. Yeah, yeah, yeah. So we'll let that one rest. Question just for me though. So literally what's happening if I could like see
Mhm.
all the little bits and pieces and little atoms and the molecules in there, and they want to switch around to create a chemical reaction. In their switching, is it that like very few of them are switching at a time, and so it's sort of like,
Yeah, so they have to bump into each other and they have to bump into each other in the right way.
okay,
So it's sort of a game of chance.
okay,
So very small molecules typically are going to
okay.
be able to bump into each other more
So
easily.
it's not that they're being let go and are like relocating over to a thing.
Mhm.
It's just that like they're jiggling. Okay. Okay. Cool. We'll cut that, but that was a little visual for that. Okay. Speaking of very fast reactions,
Mhm.
can we talk about explosions?
Yeah.
Can we talk about bombs?
Let's talk about
Is
bombs.
it too sensitive of a topic? I remember asking Dawn about the atomic bomb because
Yeah.
she said something about like, oh, like if you split an atom, and I'm like, don't do that.
Yeah.
And it's this bomb, and she's like, you're the stupidest. No, no, no. Congratulations on your new baby, Dawn. We're so happy for you. Um, God, this is 15 years ago, so more than that.
Yeah.
Forgive me if this is wrong, but she's like, well, it's like one, and then, more and more and more, and then it sort of like builds to be.
Yeah.
Can you give me a refresher course on an atomic bomb? Like what's happening in there?
Yeah. So I guess to be clear, splitting any old atom doesn't necessarily create an atomic bomb, right? They enrich uranium.
Mm-hmm.
So uranium is a very heavy element. It has a ton of protons and neutrons in its nucleus. To enrich it, you bombard it with more neutrons so that its nucleus gets very, very heavy and heavier than it would like exist in nature even.
Sure.
And then you get enough of that stuff and you trigger it to split. And that splitting releases a lot of energy because it takes a lot of energy to hold the nucleus together. Once it's split, that energy has to go somewhere, it goes out.
Okay.
one singular atom of uranium, not enough to make a bomb. But if you have enough uranium, when that atom splits, the energy released by splitting that one will hit the two next to it and make them split. And then it
Right.
kicks off a chain reaction where all these atoms split, releases a ton of energy, seemingly all at once. I mean, it does take time, but like
Sure.
from the observer, basically all at once,
Yeah.
boom. Most of the time, and I would say all of the time, bomb is not what you want. um,
Yeah, I want a bomb.
so, but nuclear fission is useful for generating power.
Yeah. Yeah.
So it's the same principle, except it's a more controlled scenario. So you don't have a ton of uranium hanging out.
Okay.
And you also have rods, which are designed to absorb the energy produced so it doesn't hit more of them. So, like
Hmm.
the nuclear meltdowns, I think there was like an issue with the rods and they weren't absorbing the energy. And so then the
Right.
reaction got out of control, melt
Right.
down the reactor,
Right.
explosion.
Explosion.
But some elements naturally, their atoms split on their own because they're just too heavy and they fall apart. So, like, there's always like that, like, oh, a banana is a little bit radioactive, right?
Everything is chemical.
And it's true that like there are unstable forms of atoms out there. Like maybe they have one too many electrons and they might just lose, or not too many electrons, one too many neutrons,
Mm.
and they might just lose a neutron.
Oh,
And that releases a little bit of energy, but not in a sufficient quantity to be
sure.
harmful. Now, obviously, there are radioactive materials,
Hmm.
uranium, for continue. Like uranium used to be used to paint watch faces and things like that. And
I was in Radium Girls in high
you
school.
were, yes.
Thanks.
Yes.
Thanks, Madame Curie.
And so that radioactivity is sufficient energy enough to be bad for you.
Yeah. Yeah.
Real quick, just for the listeners, I don't think we talked about like the structure of an atom,
Oh, yeah, true.
and we should probably refresh that an atom's basic components are a proton and a neutron that are in the nucleus in the center of the atom, and then they are orbited by electrons, which are a smaller negatively charged particle that is attracted to the protons in the nucleus. And the neutrons, the name might suggest, are neutrally charged. They have none.
Beautiful. Thank you. I should have asked that at the beginning. So good work. You talked about some elements that are radioactive.
Mm-hmm.
Can we talk briefly? I feel like we would be remiss not to mention our good old pal, the periodic table.
Mm-hmm. Love her.
Quickly, how many periodics are on the table?
There were 151. I believe we have more than that. No, that's Pokemon. Just kidding. It's 151. No, it's not Pokemon. 151 is the number of elements. There are some theoretical or undiscovered elements.
Okay, well, that's what I wanted to ask you. Who is the newest on the board? Like, when was the last one added? And who is out there digging holes in space trying to find another one to add up onto the table?
The elements that we're discovering now
Mm.
are made up. And by made up, I mean they're man-made. They would not exist in
Ooh.
nature.
Ooh, this is gossip.
Mm-hmm.
Interesting.
Yeah. So they used to get like placeholder names. A lot of them have been filled out now, but there was like Unun Buntium, which is like 1112 or something, right? Like,
Yeah. Funny. How are we creating new ones if it's not just pieces of things we already know to exist?
so there are 94 naturally occurring elements, and then the rest up to currently 118.
Okay.
151 was Pokemon. So there are 94 naturally occurring elements found on Earth, and then the rest of them, up to 118 currently, are man-made. And when I say man-made,
Mm,
to answer your question, they are, well, let me back up. The identity of an element is based on its count of protons in its nucleus.
okay.
That is what defines the properties of that element. And so, in order to man make them, basically they take a existing element that's already quite heavy and bombard it with protons to try and get them to stick. And then there's like a whole lot of like testing or whatever it does, and they have to like exist for a certain amount of time because like most of them it'll stick
Mm,
and then they'll immediately fall apart again because they're too unstable.
it ain't natural.
Yeah, and so like that's some of the work that like they do with like the Large Hadron Collider.
Oh, right.
Hmm.
That thing's cool.
Yeah,
That thing's really cool. Okay. Mm, thank you. Ready to move on entirely?
I think so. Yeah,
Can we talk about nanochemistry? I don't have any questions about it, but I know it's a thing that exists. What is it?
sure.
We don't have to.
No, I mean, to some extent, all chemistry is quite nano. But I
Right.
think what you're trying to get at is potentially doing chemistry to create like nanowire or something,
Yeah.
like the below the visible
Right. Right.
spectrum
Right. Right.
of like chemistry. Yeah, it's small. I have an example of a nanowire that they have been doing research on or had been doing research on when I was in college.
Yeah. We're into the
So,
weird section now. So
yeah,
lay it on me.
we've not talked about cooking at all.
No, I think we explained that at the beginning. We're not going to.
So, amyloid fibrils are a thing.
Okay.
And basically, they are misfolded proteins, not prions,
These guys again.
but they're really interesting in that they're very structurally strong and light and small. And we sort of know how we can produce them.
Hmm.
And so there was some research being done to see if we could coat those amyloid fibrils, produce them, coat them in metal, and then use them as like microscopic wiring
Mm.
to,
Facelifts.
improve. Well, no, electrical wiring, not like
Oh.
structural wiring, uh, to improve, like, small scale circuitry or maybe batteries, that kind of stuff. So that's an example of some nanochemistry.
Beautiful. I love things on a very small,
Mm.
just fantastic stuff, really. God, get me in front of a rice grain painter. Ugh. Okay, the last few questions I have are just more personal to you as a
Okay.
little chemistry
Nerd.
nerd.
Yeah.
Yeah.
Yeah. Let's not
It's a
sugarcoat
safe
it.
space. Okay, yeah. Do you have like a favorite experiment that you would do like as a teacher that you're like, man, this brings me a lot of joy because like the kids get it, they connect with it, or anything that you just particularly or
Yeah.
just like makes you giggle?
I wouldn't necessarily well, I mean, it is an experiment. I think it's more of a demonstration than an
Sure.
experiment, but I loved doing flame test.
Mm.
So, flame test is when you take metal, either filings or metal salts, and you expose them to flame and see what color they will turn the flame. So, like those little packets you can put in
Yeah.
to a bonfire or like fireworks have different colors.
Yeah.
It is caused by the um, specific electron configuration of that metal. Because that metal, when exposed to heat, absorbs that energy and re-emits it as light,
Mm.
and it re-emits at a specific wavelength, right? So getting into quantum.
Not a single episode has gone by.
So a quantum is just an amount of something, right?
Hmm.
So the rules of quantum mechanics state that the electrons can only exist in very specific places. And the amount of energy they can absorb and the amount of energy they can emit has to be very specific because if they were to absorb anything different, they wouldn't be able to land in a space where they exist, right? So we think of it as
Mhm.
like electrons are in ground state and they get absorb energy and they jump up to a higher energy state. Well, they
Mhm.
can't exist in the middle. They either have to be ground or next one up, right? And
Mhm.
so there's a very specific or quanta of energy that is that transition. And so they have a very specific like light signature that they will release because based on the arrangement of those electrons and the
Okay.
movements that they're allowed to make. Why are they allowed to make those particular movements? That's just the way the universe works.
Mhm. Yeah. Okay. Because the universe says so.
Yeah.
Cool. I'm sorry, I'm like giving you no feedback. I'm just like, yeah. Can I ask you, as someone who's very knowledgeable in science and chemistry, does it irritate you when you hear people, pedestrian people, average, everyday, day to day people, talk about chemicals in like a negative way? Especially in our conversation around food and exposure.
Yeah. I mean, it does. And I also understand it, right? It feels very scary. And I think it is one of the areas that best points to why we need good science education because like typically a lack of knowledge creates fear.
Mhm.
And so if people are more educated and can understand better, like they will perhaps be less um afraid.
Yeah. Well, that leads me into my last question for you from an educator's perspective, former educator's perspective. Do you have any thoughts on how we could teach science better, connect with kids better, have people, young people understand that like it's cool to know about this stuff?
Yeah. So I mean, I think that for me, this is sort of my what I've come to have as like sort of my whole central thesis for education is that it needs to be better integrated. And what I mean by that is I think especially in like elementary and middle school levels, I can sort of see the reasoning by at a higher level really like honing in on a specific topic, but
Mm,
like keeping science and reading separate from math, from history, I think does students a little bit of a disservice.
mhm,
And I think in especially in the United States and elementary schools, we focus so heavily on like getting kids to pass their like math and reading assessments. And so we keep robbing instructional time from other areas to like give more time to reading and math, but the scores aren't getting better. Um, or at least not appreciably, right? And so I think we maybe need to rethink how we do that.
mm,
Like you can read about science. You can do math in science. You
mhm,
can certainly read in history. I think often, and this was one of my frustrations a lot in high school was math and reading still gets a heavy load and they're like, well, everyone's a reading teacher. Like there's reading in your content. And I'm
mhm.
like, okay, stop reading 7 Shakespeare plays and have them read a technical manual. Like
Yeah, reading is, I think.
reading is also educating
Mhm.
on all sorts of subjects. So like I'm
Well, yeah,
happy
and
to
don't get me as a reader started on the adult illiteracy crisis that
yeah.
we have. People don't know how to read anything other than fiction.
Yeah. And that's like I think in the high school level, I'm very happy, was very happy to incorporate more reading and writing into my classes. Like I think it's valuable. Like that is the
Yeah.
way we communicate information.
Yeah.
And that is the way we like gain information. But on the same token, I think I don't know. I don't think this is true in elementary school necessarily, but I think on like by the time you start to get to middle school and even high school, so much time is spent on like the classics. And those are important, don't get me
Yeah.
wrong. But like, let's just read the Red Badge of Courage in social studies class. You know what I mean? Like,
Yeah.
um, I I think that there's and this is where I'm sort of counteracting myself, even at the high school level. Like, I think there's a way to better integrate knowledge. Um, and I think that just leads to stronger learning because you can connect it to multiple things and like you build
Yeah.
a more robust schema for the world.
No, I think I can only speak to that through my own personal experience. It wasn't until I got out of school and started living life on my own that I realized, oh my God, all of these things actually are deeply interconnected.
Mhm.
And I need to learn how to do this so that I can do the thing that I want to do. And yeah, I think science gets left behind by a lot of people because it feels so removed,
Mhm.
but it really is every single day.
Yeah, I mean, science, like, I think that is one of the reasons I fell in love with science was it helped me understand the world around me on a more deep level, but not a lot of people are getting that. Um, I don't wanna say not a lot of people are getting that, but, like, less than I would like to be, like, able to see that and fall in love with that or really understanding that, and I think I hope it's getting better. I think teachers today are a lot more aware of, like, in order to connect with students and get them to learn, you have to make it relevant to them.
Mhm.
But also to some extent, I think education is lost on the youth. Like,
I would give anything to start over again with exactly who I am now, just run it back.
yeah,
I think
it is it's
I would
unfortunate. And
thrive.
I know like there's discourse online of like, jokes on you, like math teacher, I do have a calculator in my pocket.
Don't get me started. The number of people who just punch numbers into that thing and they're like 12 times 12, C, 32,654. Jokes on you, math teacher. It's like, oh my God, babe.
Yeah. Yeah. But I also like think like, for example, at my high school, we had a personal finance class
Mm,
and the teacher always struggled to teach it. Not
I would crush
because
teaching a personal finance class.
yeah, well, and not because like the content was hard or like, but just like getting kids to engage with it. And it's so funny to me because like, you know, one of the big talking points are like, we need more personal finance in schools and blah, blah, blah. And I'm like, we had
Right.
one. They didn't care.
Right.
Like they don't care about their FICO score at
Yeah.
16.
Yeah.
And so it is really one of the big challenges of education is like getting student buy-in.
Mm,
And to some extent, like the youth can't be told. They have to learn on their own, right? Like I still have relationships with some of my former students and like I was talking to one of them recently and they were like, "Why didn't you tell me that when I was 16?" I was like,
I
"I did, but also like I could have told you that when you were 16 till you were blue in the face, but you weren't ready to learn it till now."
Yeah.
And that's just the way it is.
Yeah. And that's why all of my actual science teachers are punching the air right now seeing this.
Yeah.
Like, I did everything for her. We were all rooting for you.
Yeah.
And here I am. Yeah.
But
Mid-30s going, what's the periodic table of elements?
you know, I mean, that's the thing. It is never too late to learn. And it is never too late to find a new interest. So I think to like sort of circle back on my teaching philosophy, like I always said, I think my goal first is to like teach students how to be decent humans.
Yeah.
And then the content is like the next thing that I need to teach.
Yeah.
And like they need to know how to learn, and how to be a decent human. The content is secondary because if they can leave with being a decent human and knowing how to learn, they don't need me anymore. They can go out into the world and they can find the information. Like we have Al Gore's
Yeah.
internet. You know what I
Yeah.
mean?
Do you want to play a game?
Yeah, let's play a game.
Let's lighten it up. MASH. The Game. God, every time I go to this website, it kills
Assaults
me.
you. Yeah.
Screen. Screen. Oh, I didn't ask you if there was anything else that you wanted to share.
Your questions at the end were good enough.
Okay.
I've said my piece. So, we doing it for the Muffin Man?
Do you know the Muffin Man?
The Muffin Man?
The Muffin Man? The
Man.
Muffin Man. Yeah, as voiced by, who did we say?
A guy.
Johnny Fabrioli.
He's just a guy. Hit him with your car.
Dom
His name was Dom DeLuise.
DeLuise, and I'm sure somebody will know.
Somebody will know.
Okay.
He was apparently in Homeward Bound or All Dogs Go to Heaven. All Dogs Go to Heaven as Itchy.
Great. And I'm sure he did a fantastic job. Yeah, so he had a really powerful vibe.
Mhm.
Yeah.
Yeah. Big, bold personality.
Just a strong Italian man.
Yes.
Okay.
Yeah,
So what does that mean for his love life?
It was a little weird because, like, I don't often think of bakers as Italian, and certainly they're lovely Italian desserts and things. But I'm like, this should be a pizza place. Like, give me a French patissier.
That's crazy. Whatever you say, Matt. No, I think the trope is definitely like, yeah, French baker.
Yeah.
Yeah, Italian. Yeah. But nary a cannoli behind that.
No.
He just did very American desserts. Cakes,
Yes.
pies, muffins,
Donuts.
which love a donut. Okay.
Listen, I love an Italian sweet cream.
What are we thinking for his partner?
Who do we know? Who can we think of?
Quickly, name a woman.
Aretha Franklin. She's every woman.
Are we not going to be able to do the smash for him?
I'm trying to think. Who's an Italian woman?
Giada from the Cooking Channel.
Oh my God, if he could pull Giada, she is a smoke show.
We're going with that spelling. I'm not really confident on it. But yeah, we're going with Giada. She really talks with a lot of teeth, but like I love that for her.
Yeah.
You know who else? Maybe?
Alex Cornicelli.
Sure. How do you spell her last name?
Cornicelli.
With a C.
G.
Yeah. I think also
Martha Anstey, a throuple?
Yeah.
Okay.
Yeah. Vespa, obviously.
Always Vespa.
Yeah. I do pick Vespa a lot, but like he is Italian. So.
The rocket launcher Vespa specifically.
God, you know I love that rocket launcher Vespa. And like I do not support what Italy did during World War II. I'd like it to be known, but there are some really unique works that Vespa came out with in and around the time.
Yeah. A van. I feel like delivery van.
Just like your classic like white, Ford delivery.
Yeah. You can't put a color because colors are going to be the...
I do like to get detailed.
I know. I also feel like he might have like I don't want to say muscle car, but like
like a classic?
Yeah, or just like, like a Mustang or like a
Vet.
A Corvette. He would have a Corvette.
Yeah. Cool. All right. So
I'm also maybe basing him off of a local guy that I know that owns a pizza place and is Italian and has a Corvette, but
What color is that guy's Corvette?
I think it's a black one.
And I think the Vespa would be yellow. Okay. Well, he's obviously a baker.
Yep.
He just sticks with the bakery.
Mm-hmm.
What if he's gone like full
like TV personality? Oh.
Yeah. No, I like that like
Food Network.
Emeril Lagasse.
Yeah.
I was thinking also if he franchised his bakery and now it's like Crumble Cookie but better.
Yeah. Did you say the Crumble Cookie guy apparently is stepping back because he's burnt out? And I'm like, of course you are, baby girl.
Sure, that's why he's stepping back.
Like,
no. I will never support anyone being outed ever.
Yeah.
Unless you're a fucking bigot.
Yeah. Also, I've seen his some of his videos and stuff. He's a very intense individual. He's probably is very much burnt out, but because of himself. Like,
Yeah.
you did this to yourself, buddy.
Yeah. I think he just has a high intensity
Yeah.
for reasons. 0 children, obviously. 7 children, obviously. And he's a man, so you know what we have to do.
500.
5. Great. Where in the world is our Carmen Sandiego?
New York.
In the city?
Yeah.
Okay. He's not in like Jersey.
I mean,
Okay. Yeah.
a lot of great Italian representation in the city. A lot of great Italian food. A lot of great Italian sweets.
And I love them. And I love them. My favorite Italian sweet is my brother's wife, Krista. She's my favorite Italian sweet.
Amazing.
Okay, where else is he? I mean, if he's a TV personality, he definitely has to go to LA.
He could be doing that in New York, but yeah, probably LA also.
True.
I feel like a decent amount of Food Network stuff might be filmed in New York.
Yeah. Where else globally could he be?
Picture it. Sicily.
Oh, obviously. He moves back to Italia.
Yeah.
Do we think Sicily?
I don't know. I don't know my flavors of Italians very well to understand where he was aiming for with that accent.
And it was an inconsistent accent. I love that for him. Are we ready to predict the future?
Yeah, let's do it.
Okie dokie. Oh my gosh. Oh. Oh, wow. He's busy. Our boy is busy. So our Italian baker man ends up with Martha and Snoop and 525,600 children. He has a yellow Corvette parked outside his home in Sicily.
But he has franchised that bakery.
Yeah, he's franchised the bakery. Maybe it's sort of like an orphanage.
He has a child running each bakery.
Oh my God, not the child labor. My God.
It's on every corner.
I love that this happens every time we do it. Every time. Twice now. We've been able to run just an egregious number of children.
Yeah.
I think I'm happy for him. I like that it's Martha and Snoop. They can sort of come and go I didn't mean to say what I said. They can travel freely. You know?
Mm-hmm.
I just think it's like a really beautiful collaborative life. And Martha obviously gives him fantastic advice on his franchise because she's a great businesswoman.
Yeah.
Snoop keeps the vibes high. I love this.
Well, Sarah, thank you for potting with me this week. We'll be back again next week with season 1, episode 10, Magic School Bus Plays Ball. We're going to learn about forces.
That's physics.
Mm-hmm.
If we finally get a physics episode.
We had sound last week.
Oh yeah.
I think we're in our physical science era.
Okay, queen. All right. Well, we will catch you next time.
Bye-bye.
Bye. Well, that's a wrap on our Yap session for this week. If you enjoyed the episode, subscribe and share. We can be found on Instagram and TikTok at A Girl and Her Gay Watch and on Blue Sky at The Girl and Her Gay Pod.
If you'd like to get in direct contact with us to ask a question or submit a correction, send us an email at agirlandhergaywatch@gmail.com. We would love to hear from you.